Hey everyone! One of the most common flat Earth claims is that day and night can work just as well on a flat disk with a small close sun moving above it. Today we're going to test that claim with two objects and a lamp, nothing fancy, just what you can do at home. In my left hand I have a basketball representing a globe Earth. In my right hand a flat disk for the flat Earth model. This lamp will be our sun. Let's see which one actually produces what we see in real life. First, let's establish something both sides agree on. At any given moment, half the planet has day and half has night. The dividing line, known as the terminator, is always a perfect circle. When viewed from space, also when it's noon where you are, the sun is almost directly overhead. 12 hours later, it's midnight and the sun has completely disappeared below the opposite horizon. Let's test that. I'll turn on the lamp and point it at the basketball from a few feet away. Look, one half of the ball is brightly lit, representing day. The other half is completely dark, representing night. The boundary is a perfect circle, exactly like what we see in satellite photos. If I spin the ball slowly, every point on its surface gets about 12 hours of day and 12 hours of night. When I imagine standing where it's noon, the lamp, our sun, is almost overhead. When I move to the opposite side, the lamp is completely hidden. Below the curve of the ball, it's midnight. This is a perfect match with reality. Now let's try the exact same thing with the flat disk that flat Earth models use. I'll hold the disk vertically, facing the lamp. What do we see? The entire front side of the disk is lit, and the entire back side is dark. This would mean that on a flat Earth, when it's daytime on one side of the disk, the entire planet has day at the same time. The other side would have permanent night. That's already wrong. We know Australia and America have opposite day and night right now. Okay, but flat Earth proponents say the sun is small, close, and moves in a circle above the disk. So let's try that. I'll bring the lamp in close, about 6 inches above the center of the disk, like a spotlight sun. Now we get a circle of light in the middle and darkness everywhere else on the disk. We run into problems immediately. The edge of the light circle is fuzzy, not a sharp, defined terminator line that goes from horizon to horizon like we actually see. People thousands of miles apart, say in Brazil and South Africa, would both see the sun at the same time, almost overhead. But in reality, when it's noon in Brazil, it's the middle of the night in South Africa. Most importantly, on a flat plane, once the sun is above your local horizon, you could turn 360 degrees and always see it. There's no direction where the sun sets below the opposite horizon. It would just get lower and dimmer in the distance, never fully disappearing below a curved horizon. Yet every single one of us, every day, watches the sun drop below a horizon that is curved and disappear completely. So here's the bottom line. The globe and a distant sun give us a perfect circle of daylight, a sharp curved terminator, and a sun that rises and sets below opposite horizons, giving us about 12 hours of each. It matches reality 100%. The flat disk with a close spotlight sun either lights up the whole side at once or creates a fuzzy circle of light with no true sunset in any direction. Only one of these models actually produces the day and night we all experience every single day. You can do this experiment tonight with a ball, a plate, and a lamp. See for yourself. Thanks for watching. Keep questioning, keep testing, and follow the evidence wherever it leads.